Okay, I wanted to make a screencast here just to clarify a couple of things that we've been looking at in class on our section on counting methods. We're looking closely at how to determine how many combinations there are, large numbers, factorial notation, that sort of thing. So just to help clarify some things, I want to we've been looking at taking subgroups of groups. So let's just look at an example where, say, we've got 4 people. 4 personnel A, B, C, D, and if we're looking at, say, looking at breaking them up into twos, so looking at the number of arrangements, which is I think the word we've been looking at, the number of arrangements of 2 from those 4. Another word for arrangements is permutations. So I'm just gonna give, language is so important here. So the number of arrangements or permutations, might see that word used a little bit, of 2 from 4. Okay, so let's have a look at that. So let's have a look. We have AB would be 1, AC and AD, yep. And then we'd have BA, BC and BD, and we haven't been listing these out. I'll explain. The reason I'm doing it now is because I just want to show something here. DA, DB, DC. So if we listed them all out there, they'd be, there's 12 arrangements there, or what we're going to call permutations. We haven't been doing it quite like that. We haven't been listing them out because sometimes there's 600 of these things. But we've gone, right, well, if there's 2 slots, if we're looking at groups of 2, we're saying to ourselves, we've got 4 from which to select in our first spot, and in our second spot, any one of those 4 can be joined by any one of 3 in the second spot. Once that first one's come out, we've been multiplying them together and saying, right, well, that's 12, and you can see that matches up nicely. But what we're finding there are the number of arrangements. So for instance, you can see that AB and BA are counted as 2 permutations, 2 arrangements. So the purpose of what we're looking at now is to sort of ask the question, actually, do we want that to count twice? Is that something we want to count twice? Because there's plenty of situations where really all we're interested in is the number of what we're going to start to call combinations or selections of 2 from 4. So we don't want to distinguish between AB and BA. It's the same group. It's the same selection. So that's where I'm going to start to differentiate this. So the number of selections, which is the language used in the book, number of selections, I'm going to call them combinations, same thing, of 2 from 4. Now here, we're not now interested in, so AB, this BA is not a different AB in a combination. It's a different permutation, it's a different order, but it's not a different combination. So I'm going to get rid of that. AC and CA, they're the same. AD and DA, the same. BC is the same as CB. BD is the same as DB. They're the same. I lose half of them. So actually, the number of selections of 2 from 4, what we end up doing is we end up taking the 12 that we had before and dividing by 2 factorial. Now 2 factorial because we're looking at combinations of 2. And there's 2 factorial ways of arranging each of those, each of those little arrangements of 2, if you like. So that's equal to 6, and we can see there 1, 2, 3, 4, 5, 6 is correct. Now, all right, I'm going to make a point here of, with permutations, order is important. And there's plenty of occasions where order is important. Now, first, second, third, that's important. But if we're just looking for groups or combinations, selections, then order is not important. And if it's not important, we need to modify our calculations. Order is important, order is not important. Okay, so let's go to how these are actually calculated. If we wanted 4, so how to calculate. Okay, so if we want how to calculate, so we want groups of or permutations of 2 from 4. So if we're looking for permutations of groups of 2 from 4, from a larger set of 4, this is 4p2, and I'll show you how that's found in the calculator. It's in here under menu, probability, permutations. It comes up NPR. We put in there 4, 2, and we hit enter, and we'll see 12 come up. 4p2 equals 12. So on the calculator, that looks like NPR 4, 2, and that's found under menu 5, 2. Menu 5, 2. Okay. Get back into there. That's menu 5, 2. Right, they're the 3 buttons to hit to get in there. So if we're after permutations of 2 from 4. Remember, order is important there. So A, B, and BA are different. Combinations of 2 from 4. So now order not important. A, B, and BA, we don't want them to be different. We're going to look at this as 4C2. So we're going to go in here, and we're not going to get NPR in this case. We're going to find NCR. So in the menu, 5, 3 for combinations, 4, 2, and you'll notice here that the calculation comes out to be 6. So we go back, and that will equal 6, and we saw that up here. Okay, so that's how to calculate. So on the calculator, it's NCR 4, 2, and that goes menu 5, 3. They're the 3 buttons to go for. Right. So that's how the calculator will go for it. I'm just going to for permutations, NPR is calculated n factorial over n minus r factorial. For NCR, it's NCR equals n factorial over r factorial n minus r factorial. So it's just this r factorial is the difference. This is divided by that r factorial over here. We were dividing by 2 factorial because that was our r. Okay, let's have a look at just an example from the textbook. So say 12C, so exercise 12C, question, let's have a look at question 5. I don't know if that's on your work requirements. It's how many netball teams of 7 can be chosen from 13 players. So we've got 13 players, team of 7. Now, do you think order is important here? No, we're just after groupings of 7, so we don't want the same 7 personnel to be counted any more than once. So order is not important, so it's a combination. So 13 players, so we will go into our calculator and we will choose 13C7. So we'll go in here and go to order not important, so I'm going to choose combination. There goes the telephone. Hopefully someone will answer that in a second. Fantastic. 13, 7, hit enter. 1,716 teams. 1,716. So there's 1,716 ways of choosing a team of 7 from 13 players. Surprisingly large number. It'd be much greater if that was a team of 7 where the order was important. So they had, perhaps you were looking at a positional team of 7. So with a different ways you can play that team. That would be 13p7, a much larger result. Anyway, hopefully that's enough to go on with, and maybe that clarifies a little bit in your mind about the difference between permutations and combinations, or as they're called in the book, arrangements and selections. And take the notes down and head on to just get started on 12C, and we'll see how you're going in tomorrow's lesson. Okay, cheers.